Mario Cucinella Architects.
Good evening. As you can see from the title of this presentation, I will speak about the connection between form and performances of the building. So, does it work? Okay. The importance of resources. Let's start with some numbers. Today, the Earth carries 145 billion of square meters of buildings. That account for 15 gigatons per year of CO2 production. That it means that it's 47% of the global greenhouse gases emission. But the most important thing is that by 2013, we can expect other 73 billion of new square meters of buildings. And these numbers are really huge. And you can imagine that if we continue to build the building as we do today, it will be a very huge problem. We will reach the no-return points. So as you can see, this is the planet Earth as we know. This is the normal image of the planet Earth. But if we look at the Earth from a different point of view, and actually the different point of view is the ecological footprint, you can see that is a deformed world in which some part of the world are consuming a lot more than other parts. And of course, this is a very huge problem for the future of our planet. So, the importance of resources. Today, they are very relevant, some issue, as for example, energy, water, waste. But tomorrow, they will be extremely relevant: energy, water, biodiversity, climate, outdoor amenities. So, that's the point where we start to design building. So, our vision is responsibility. So we have to work in a responsible way to make buildings that consume a lot less energy than what we are doing today. To explain that, I will start with a picture. It seems a funny picture. There's a funny guys in the desert with the camel. But actually, if you look at the picture from a different angle, you will see that that funny guy actually is a doctor that is walking through the desert with a camel, with on top a fridge with medicine inside and a PV cell. This picture, in our way to see architecture, it's what we like to do. So to use the tradition with new technologies to make building that really works and consume much less energy. So after this short introduction, I will start showing a few projects that we did starting from this principle. So the first project is One Airport Square. It's in Accra, Ghana. It's already built project. Actually, they finished this year. And so the first issue, of course, when you are making a building is the climate. So in this case, it's a tropical savanna climate. And of course, the main problem is the hot weather, of course. This is the location. It's not very interesting, but you know, this is the solution. I mean, overhang as a passive cooling strategy. So normally, the normal way to make a building, let's say, to cool a building is to put a lot of equipment, close the windows, and air conditioning system, and that's how we normally do. But this is a very simple and easy solution. So using overhang as a passive cooling strategy. So just using the shading to make the building consume much less energy. So these, of course, are sketches of the building. This is the building. Now I will show a few pictures of the building. This is the building, and as you can see, it's also kind of very simple and brutal building. It's just floor plates and a diagrid and a structural diagrid. And the rest is made by the overhang system that screen the facade from the sun. And this will reduce a lot the needs of energy to refresh the building. So a very simple solution makes the building very efficient and also very beautiful, I would say. So, and you see how we get the inspiration from the local tradition and local also picture. This is a part of a palm tree. These are the traditional houses in Ghana. And that's what we get. So thanks to the overhangs, we can reduce 50% the cooling peak during the day. And that's, these pictures are just to show that with some computer program, we managed to investigate all the different problems. And this show really well as the building works. So it's not a closed building, but there's a big atrium to refresh the building and a system of overhangs that screen the old building. So you see here is the atrium. It's a very high atrium, and those are also other pictures of the building. This is just optimization the structure, so to minimize the use of the material. So through parametric program, we were able to minimize also the amount of concrete in the building. And it works really, really well, as you can see. So it's a four-star Green Star certified. That is a good result for West Africa. And then I will go to the next project, that is Algerian Post and Telecommunication Authority Headquarter in Algiers, in Algeria. So, as always, the first issue is the climate. Here we are in a hot summer Mediterranean climate. And also here, the principle that we used to make the building was the shading. So, using the tradition, so the musharabia, that it's the way that in the Arabic country they used to shadow the interior, so to have a fresh room, also if outside it's very warm. And that's the building made starting from that principle. In this project, apart from the shading, actually we worked a lot also with the shape of the building. Because actually we get inspiration from the desert dunes and also from the traditional Arabic arcs. That, as you can see in the next slide, it generates all the plant and also the facade. Everything is done using this element that is very strong in the Arabic tradition. So, as you can see, is always in this project. This is the section. It's also rendered. It's very interesting because, as you can see, the shape of the building is very similar to the turret. That actually is a system that they used in the past around the Mediterranean Sea to collect water during the night time. And that's exactly how our building works, because let's say from this side, I would say during the night, the cold wind is reaching the building in this direction, and then we collect the cold air, and we refresh the building during the night. So that's the principle, as you can see. Then there's also other strategies, but the time is running very fast, so I will go a little bit further. As you can see, this is the screen, is the, let's say, new musharabia that we designed. And these are all the solar analysis from radiation of the sun, and also, so this screen is optimized on the sun position during the year. So it's not all the same, but it changes depending on the side of the building. So we also already tested this solution, and it seems to be working. This is the comparison between our building and normal office building in that area, and actually we found out that we save 71% of the energy in our building respect on a normal one. So this is the last project, also if I almost finished the time, but this is a very strong project. I would like to speak about it. This is the KUWAIT School in the Gaza Strip. This was a very difficult project for the location and also for, let's say, the political issue around it. Here we are in hot semi-arid climates. Of course, climates is always the starting point because you cannot do a building without considering the place where it's placed. So in this case, we have a lot of problems. What happens if there's no water? What happens if there's no electricity? There are no construction material. This is the Gazan daily life, so it's really difficult to live and to build over there. So that's the situation. So as you can see, it's in the Gaza Strip, very tricky place. So how we can design a building capable of overcoming the country challenge? That's how we do. Okay, this is the building. So we use thermal mass, natural ventilation, and shading equipment. So we use thermal inertia. And actually, we reach that solution using actually filling the pipes that there will be the structure of the building with the earth of the work site. So actually, we just move the earth from the ground inside this huge concrete pipe. And then WINDCATCHER, that is also a traditional form of natural ventilation that they use in the Mediterranean area and also in Asia. We can make the building breathe. Let's say we extract hot air from the top and we refresh it from inside. So these are simulations that confirm that it works in this way. This is the same Musharabia. So actually we shade the facade with this object that they are also combine a very nice design and they work really well. And so that's what we get as a school. And of course, it's very different from all the other schools that they are built in that area. They are really, really bad. Concrete boxes is almost impossible to learn there because it's really difficult situation. So this is the school that with the use of simple technique, we can reach a very strong building that works really well. Actually, we spared the 60% of water demand. We don't use any electricity, and of course, we don't use any heating system because we are in Gaza. It's not a problem. So during the summer, we have a big roof that screens the facade and it collects the water. And so we don't use any oil and we don't emit any CO2 with this building. And this is the inner court of this building. Actually, I should show another project, but there's no time, so no problem. No, it's enough like this.
It's okay. Thanks.
Yeah.